Another 6-5 topic was simplifying these fractions up. So I'm gonna give you one example here. Okay, so if you were asked to simplify that, so that's blurry. There we go. If you're asked to simplify that, you want to start it off kind of the same by breaking it up into its perfect cubes this time. So you're always basing it off the index. Here we're looking for things that are perfect cubes. So 16 is not a perfect cube, but I can break it down into 8 times 2, and 8 is a perfect cube. I have 3 copies of x, I have 2 copies of y. And then I'm going to do the exact same thing in the denominator. Split it off into its own cube root. 5 is a prime number. I have 2 copies of A. I have 1 copy of B. Okay, so here's how these problems work. First of all, you do want to simplify anything that comes in a group of 3. So 8 is a perfect cube, so I'll be able to break that out. The x's are a perfect cube because they come in a set of 3. The denominator has to be perfect cubes. I am not allowed to have a radical in the denominator. So as of right now, none of them are perfect cubes, which means you have to turn them into perfect cubes because I'm not allowed to have a radical in the denominator. So I have to be able to bring everything out of the cube. So it means I have to turn them all into perfect cubes. So 5 is a prime number. In order to turn it into a perfect cube, what I have to do is multiply in 2 extra copies of 5. Okay, so I have 5 times 5 times 5. That comes in a set of 3. That means I'll be able to break it out. But if I multiply something into the denominator, I also have to multiply it into the numerator. Okay, so that's where we're at so far. I have a bunch more stuff under here. A's. I have 2 right now. I need 3 in order for it to break out of my radical. So if I have 2 right now, I need to add a third, which means I also need to add a third into the numerator. And then for B's, I only have 1 right now. I have to have 3 so that I can get out of the radical. So if I only have 1, that means I need to add 2 more so that I have a grand total of 3. And I'll do the exact same thing in the numerator. All right, so let me just extend these. There we go. Okay, so now we are looking at everything that comes in a set of 3. So we have 3 5s. If we kind of... There we go. We've got a set of 3 5s. We have a set of 3 A's right there. And we have a set of 3 B's. I could have rewritten this in order, but apparently I chose to do that. In the numerator, nothing else comes in a set of 3. So here's what we're going to do. We're going to break out everything that is in a set of 3 and then leave behind anything that's not. So 8 is a perfect cube. The cube root of 8 is 2. These x's, since they come in a set of 3, I can bring an x out from my cube root, and then I just leave behind everything else because none of the other stuff comes in a set of 3. Make sure you always still rewrite your index because without the 3, it's a square root, and this isn't a square root. So for numbers, I have 2 times 5, which is 10, times 5 again gives us 50. And then I have 2 copies of y, so that would be a y squared. I have 1 copy of A, and I have 2 copies of B. Okay, so those are all the leftovers. Those are all the things that did not come in a set of 3, so I had to leave them under the radical. In the denominator, everything should be out now. So I have a set of 3 5s. So that's 5 times 5 times 5. So that's 125, and the cube root of 125 is 5, so it can come out. I have a set of 3 A's, so that's A cubed, and the cubed root of A cubed is just an A, so that can come out. I have 3 B's, which means a B can come out. So my denominator is now completely free of the radical, which means that I am totally simplified because you're not allowed to have radicals in the denominator. One thing, please remember you cannot reduce things that are underneath a radical with things that are not. So it seems really tempting to reduce like the 5 and 50 or the B's or the A's or something, but you can't because these things are under a cube root and these things are not. So this is not actually 50. It's the cubed root of 50, which is some strange irrational number, and it doesn't have anything in common with a 5. So this is as far as you'd be able to take this example.